Dr. Parthasarathy is a multifaceted person. In addition to anesthesia from Japan, he studied statistics, acupuncture, and working as a professor from Mahatma Gandhi Medical University from 2018. He's a life member from IMA, ISA, and he's the editor in editorial journal Anesthesia, and associated from IIJA, and his own YouTube channel Pain Free Doctor. Welcome you, sir.
Good afternoon, everyone. So, people next to me are waiting for Vande Bharat train. So, instead of passenger train, I will also lead the lecture like Vande Bharat. Okay? So, first of all, I would like to congratulate by giving a good class to Dr. Edward Johnson and his mentor, Dr. A.L. Amsar. Thank you very much for this opportunity. No. Big slides, colorful slides are there. My slides will be colorful, but in a different way that Dr. Sudhish knows, okay? So whenever I talk anything on academics, I put a big salute to my legendary teacher of 2 centuries, Professor Ravi Shankar, and my institute, Dr. Mahatma Gandhi Medical College and Research Institute. So there is a lot of confusion of what is an acid, what is a base. Sometimes anions are called acids, sometimes anions are called bases. So what is an acid is a big question, okay? Now I will tell. An acid is a hydrogen ion donor, okay? Hydrochloric acid, it donates hydrogen ion, so it's an acid. Carbonic acid, it donates hydrogen ions, so it's an acid. So acid is a hydrogen ion donor. So you can see phosphoric acid, H plus H2PO4 minus, okay? Now a base is a hydrogen ion acceptor. Now you can see this is the thing. This is the base. It accepts hydrogen ion, and this is an acid which donates hydrogen ion. Very simple it is. So acid is a hydrogen ion donor and base is a hydrogen ion acceptor. So this is what is. Now there is one more confusion. Okay? That confusion will come now. What is an alkali? Alkali produces hydroxyl ions in solution. So this is sodium hydroxide which produces hydroxyl ions. So more of hydroxyl ions, a strong alkali, more of hydrogen ions, strong acid. Now we are clear now, acid, base, alkali. Acid is a hydrogen ion donor, base is a hydrogen ion acceptor, alkali is a hydroxyl ion donor. Now in Sorensen, 1909, he found even a small change in the acidic activity of our body, there are a lot of changes in enzyme activity. If it becomes 7.36 to 7.3, there are a lot of problems in enzymes. Okay? So 0.0001 moles per liter is equal to 10 to the power of minus 4. You can see here 0.0001 is equal to 10 to the power of minus 4. Now what is this? 0.0001 is equal to 10 to the power of minus 7 moles per liter. Now I have got an hydrogen ion concentration of 10 to the power of minus 7 moles per liter. I understand. We cannot understand. So what we have coined is, we have coined like this, like 4 and 7. Right? This like, because it is 10 to the power of minus 7 moles per liter. If you write it as 7, it is fine. So that point they coined negative logarithm of hydrogen ion concentration. So if you say 10 power minus 7 negative logarithm, then it becomes 7. That is what is called the pH. pH is a term coined as Poisson's hydrogen or power hydrogen. So that is the word called pH. Okay. Now pH change and hydrogen ion concentration are never linear. If the hydrogen ion concentration is increased from this much to this much, pH may not decrease the same thing. அதுலேருந்து அது போகும்போது pH may decrease further. So they are not linear. So what is neutral pH? Neutral pH we know 7. 7 is the neutral pH. In chemistry, 7 is a neutral pH because pH of water, H plus and hydroxyl proton 10 to the power of minus 14. They have found out H plus and HOH is the same way. This is 7, that is 7. So that is why they call the neutral pH as 7. And our blood is slightly alkaline according to chemistry. So our நம்ம சாதாரணமா சொல்லும்போது 7.36 to 7.45 is normal pH, 7.35 to 7.45. But in chemistry if you say it is slightly alkaline. But 7.3 in medical terms is acidic. Understood? Are you clear? What is your name, pa? Very good, pa. I think you are the worst person to say I am very clear. So pH of 7 is oxidation is impact. So lactic acid is a stronger acid. I have already told. Which acid is stronger acid means solution more hydrogen ions. If it gives, then it is a strong acid. Okay, this is a strong acid here. Lemon juice, gastric acid to bleach and soapy water to go to 10 to the power of this thing, 14. Now our life is acidogenic. We are continuously pouring hydrogen ions, acids. Our life is continuously putting hydrogen ions. What is this non-volatile acid? Lactate, protein, phospholipid, and volatile acid is carbon dioxide or carbonic acid. Volatile na respiration it will go out. So carbonic acid is a volatile acid. Pyruvic acid, lactic acid, all these things are non-volatile acids. If எது ஈஸியா எக்ஸ்கிரீட் ஆகும் நமக்கு? volatile acid ஈஸியா எக்ஸ்கிரீட் ஆகுமா? நான் volatile acid like pyruvate, lactate எல்லாம் ஈஸியா எக்ஸ்கிரீட் ஆகுமா? volatile, very good. So volatile, why I am pressing now? You should know. And the pre-op questionnaire இதெல்லாம் இருக்கு, pre-lectureல. So after the lecture you should get 100%. That is the aim. Okay? So yes, this has already been told already. So what is a buffer? Now you have a solution, 7.35 is the dead pH. You add acids. Now it doesn't become 7.1 or 7. So there are a lot of systems in the body which buffers this change in pH. Although acid actually it would come from 7.3 to 7.0, but it doesn't come. So something is happening. That is what is called buffering. The fast pH changes are not allowed. Okay? The body's chemical buffer system consists of carbonic acid plus bicarbonate. There are phosphate buffer, protein buffer. Now you can see here. This is a buffer, carbonic acid plus bicarbonate. If you add strong alkali. Now if you are adding a strong alkali here, it becomes a weak alkali. That is what is the buffering. Now if you add a strong acid here, it will become a weak acid. Now if you are adding a strong acid here, it will combine with this and will become a weak acid. So this system of HCO3 and H2CO3 is called a buffer. This is one of the most important buffers of our body. Okay? Carbonic acid plus bicarbonate buffer. You know Anderson Hasselbalch, HCO3 by H2CO3, we leave it. There is one more thing called phosphate buffer system. You can see here Na2HPO4, idhula pathina hydrogen 2. Okay? Now if you add HCl, Na2 will become NaH2. If you add hydrochloride base, this will become otherwise. Okay? Now again I will show you. This will become like this. See, this system is available in kidney tubules and RBCs. Now we know bicarbonate carbonic acid system, phosphate buffer system and protein buffer system. Protein buffer system la amino groups are positively charged and negatively charged are carboxyl groups. Now these hydrogen ions and this will cause, so here hydroxyl ions amino groups oda pedum, hydrogen ions carboxyl group oda poi, now they will buffer. There is something called HCl with hemoglobin and weak hemoglobin, weak acid and its potassium salt. Same thing, acid and its salt. This adds, now you can see acidic is added, it becomes like this. It becomes a weak acid. Now what is the contribution? Bicarbonate is the main thing. Then hemoglobin, then phosphate, then plasma protein. Okay? Now can we go ahead? No, but response. I think they need Colgate or close up. Okay. Now this is thing. Now you see the plasma pH. Acid is added. Now there are lot of receptors, peripheral chemoreceptors. They increase ventilation. They will decrease PCO2 and plasma pH is normal. Now if you are adding some acids, you will breathe like this. Wash out carbon dioxide. Carbonic acid is gone. So then the pH remains the same. Okay. Doubling the respiratory rate for less than 1 minute, removing extra carbon dioxide would increase the blood pH by 0.2. There are a lot of receptors, medullary receptors, peripheral receptors. Up to 7 stimulation hyperventilation, but below 7 it may not have the effect. Think of Kussmaul's respiration. Okay. Diabetic ketoacidosis. There is a ketogenic influence. Lot of acids are produced. Now the patient starts washing out carbon dioxide and carbonic acid. So this is what is the respiratory compensation or regulation. Now if you give massive doses of carbonate like this, now PCO2 increases and pH remains the same. This is exactly, it doesn't happen like that. Now we have respiratory regulation, we know. Now we know renal regulation. I'll go fast. There are 3 mechanisms. The first mechanism is, now the acid is excreted from here to the urine here. If you add acid, the acid is excreted and here you can see carbon dioxide is absorbed. This is hydrogen ion secretion. Your kidneys secrete hydrogen ion. That is one form of renal compensation. There is another form of renal compensation by adding this and secreting like this, sodium dihydrogen phosphate. The third one is making NH3 into NH4 plus. So these are the 3 mechanisms. Carbonic acid, NaH2PO4 and NH3 to NH4 plus. Renal regulation. Now we know respiratory regulation, renal regulation, and the next is urine pH. You all know vary from 4.5 to 7.8. I don't know, many people will know the normal urine pH of a normal person. Anybody? Doubt irukilla? Edward has already told, in between don't ask questions. So don't worry. ECF mechanisms are instantaneous. Respiratory mechanisms will take few hours. Kidney mechanisms may take lot of time. But the kidney mechanisms, complete excreta, it is permanent. Now there are 3 mechanisms. ECF, respiratory, kidneys. Now there are term called acidosis. Acid, we don't confuse with acidosis and acidemia. Acidosis, pH is less than 7.3. Metabolic and respiratory. Alkalosis, metabolic and respiratory. There are compensations. I am very clear. There is a difference between buffer and compensation. Buffer, acid, strong acid, weak acid, it is staying there only. But if you add an acid and the patient is excreting out of the body, then it is a compensation. So there is a clear difference between buffering and compensation. The hydrogen ion gets out of the body is compensation. Okay? Alkalosis, acidosis, metabolic, respiratory. Acidosis, metabolic, respiratory, alkalosis, metabolic. Now we have increased non-volatile acids, hypoxia, the commonest cause. If normal, Shilpa, okay. Now you are giving oxygen to the tissues. Glucose gets converted to 36 ATPs. And now this conversion gives carbon dioxide and water as the end product. Water kidney level, carbon dioxide lung level. If the tissues have got no oxygen, then only there are 2 ATPs, energy is gone. Then what happens is these non-volatile acids are produced. They cannot be excreted. Oxygen இருக்கும்போது ATP high, volatile acids are coming out. They are the end products of glucose metabolism. But here it becomes lactic acid and pyruvic acid. And what is this called? Non-volatile acid increase ana. What is it acidosis called? Metabolic or respiratory? This is combined. Metabolic. Volatile acid, carbon dioxide increase ana respiratory acidosis. Now this acidosis is metabolic acidosis. Now we have increased, for example, a foreign body throat is not able to breathe. Carbon dioxide is going up. For COPD, carbon dioxide is going up. Some bulbar disease, patient is not able to breathe. Carbonic acid is increasing. Carbonic acid is increasing is what acidosis? Respiratory acidosis. No doubt, no? Okay. So non-volatile acid, metabolic, respiratory is volatile. Now what happens in vomiting? Continuously the person can vomit out. What happens in vomiting? Hydrogen ion goes out. That means the patient will develop alkalosis. What type of alkalosis? Metabolic. Very good. So this is hydrogen ion is getting excreted and this is metabolic alkalosis. When the patient gets pneumonia with hyperventilation, pneumonia nada. See, there is a difference here. 2 functions of the lung. One is oxygenation, another is ventilation. That is excreting carbon dioxide. 2 functions. Now the patient is getting pneumonia or ARDS or pulmonary edema. Patient's primary problem is hypoxia or type 1 respiratory failure. After he will start breathing to overcome this hypoxia, then you will wash out carbon dioxide. Carbon dioxide எல்லாத்தையும் வெளியில போயிடுச்சுன்னா carbonic acid outனா what is it? Alkalosis. What is alkalosis? Respiratory alkalosis. Very good. So, okay. So what is an acid base? What is an alkali? Clear. Hydrogen ion acceptor, hydrogen ion donor. Buffer is what? Resistant to pH changes. There is acidosis means 7.34 kPa. Alkalosis means more than 7.45. There is a metabolic means non-volatile acids are increasing. Respiratory acidosis means volatile acids are increasing. Thank you very much.
Thank you, sir, for the marvelous presentation. Really, you made me recollect many things, sir. I understood many things better today. Thank you, sir. Thanks a lot. And I believe our children will also be benefited, sir.
I request the chairpersons to honor Dr. Parthasarathy, sir. I request Dr. Ravindran, sir, to honor Dr. Muthushandam, sir, and Dr. Ratnamar, sir. Regional and